Yeah. We've settled on a window that we like, and you might pick it. That's fine too. Where's the, I haven't answered Lauren's question yet. Where's the average? Good. Jacob looks right back over to that board, because that's where it's written down. The average is negative 15. Where's the average? Tell me where to stop. What's that right there? That's 0. Y-axis, huh? Remember, don't forget all your math from before. Pounds changed. I'll put changed instead of lost. That way, positives are gains and negatives are lost. Okay, good, good. Okay, so tell me where to stop.
Stop.
Ah! Isn't it right there?
Yeah.
Remember our scale was 10. If that's 0, 10, 20, 15. Go so tight. So here's your average right there. We're going to call that, I'm going to put on the horizontal, I'll put that actual number of negative 15. What does that do to the data-ish? What does it do to the data-ish? Cuts it basically in half. It separates the lowest 50% from the upper 50%. That's a consequence. Now, technically speaking, which statistic is supposed to do that? Always. What statistic always cuts the lower half from the upper half? The median always does it. But when your data is bell-shaped, you might remember that the median and the mean are about the same number. Boom, bell-shaped data, essentially the same number. You can also see your 75% from before of weight loss. This half of the data all lost weight. The half that's over here, half of that half lost weight. Half of half is 25%. Yeah, 25%. That 25% plus that 50 is roughly your 75. Yeah, pretty sweet. But now, again, if we just stop there, though, what we've done is we've lost the quantification, as Susan asked for before, the quantification of how much weight was lost. Clearly, people that lost, these people here, lost less weight than these people down here. And these people here gained less weight than these people over here. Fair enough? So the further you get from average, the more extreme your weight change got. So the question is now, can we quantify how far away from average we get? I think we can. I think we can. Lauren, here's the answer to your question. Let's take the standard deviation. Richie, you said plus or minus earlier. Can we use that idea?
Sure.
Richie said plus or minus from the average. Let's take the 16 pounds and stack it on the average up and down. Okay? So start with negative 15. If I add 16 pounds to negative 15, I should get 1 pound. Right? That goes up to 1. So that's going to put me right about here at 1. And if I drop 16 pounds to the negative 15, that's going to put me down at negative 31, which is going to be ish here. Symbolically, what I just did was I took x bar here and added the little guy s to it. And symbolically here, I took s bar and subtracted s from it. That's symbolism. That's, I mean, if you're going to use algebraic symbols. The reason I like doing that is because it's easier than saying, take x bar and then add little s to it. You can just write the symbols down. You guys okay with, I saw fear in some of the faces. I'm sorry. We'll get used to it, I promise.
So what you did is you added to the average your standard deviation.
And then I subtracted it.
And subtracted.
Yes. What I have just done, thank you for that question, sir. Because what we have just done now is we've set up a range of values from negative 31 to 1. How much of the data, or quantify it, lot or little, how much of the data is in there?
A lot.
Quite a bunch, right? Quite a bunch of it. 2/3, is that what I heard? 2/3. Yeah, it looks about 2/3, doesn't it? Matter of fact, count it. Look at your raw data. We're cheating a little bit here. We're cheating a little bit because you wouldn't have this, right? Realistically. But since we're cheating a little bit, go count the data. How much of the data fell between negative 31 and positive 1? I'm going to pull this out while you guys are counting that so we can see the entire board.
This is where Excel would come in handy.
This is where Excel would come in very handy. Yes, Carolyn, I agree.